is the following statement true? That if you have two integers, for all integers a and b, if a divides b and b divides a, it must be that a and b are equal to each other. A is b. Well, this on the surface level might seem obvious. Let's go ahead and try and think of some examples, right? Let's think of, for example, 0, 0, right? I've already kind of done a proof with that. So if we have 0, 0, well, this is absolutely true because 0 is equal to 0 times any integer, whether this k is 0, negative, positive, doesn't matter, still going to be 0. So for 0, 0, that's seeming to be true that they have to be equal, because you can't have 0 and 1 and then 1 divides 0, because we know this is true, but we know that is false, right? Because this up here would mean 1 can be written as 0 times k, but if we rearrange for k, k must be an integer, but we're saying k must be 1 over 0, and you can't divide anything by 0. So we know this up here is false. We know this down here is true, because 0 can be equal to 1 times k. It's just that k here must be an integer, and it must be a specific integer. K must be equal to 0, so that's true. But we're checking for cases where both must be true. It must be both the case that a divides b and b divides a. We're only looking at numbers where this is true, and then we're checking that when this relationship is always true, that this inherent pattern is true. So another thing you could look at is, let's say 1 divides 1. Well, that's obviously true. 1 can be written as 1 times m, where m here would just have to be equal to 1, which is an integer. Fantastic. Okay, so this case does look like they have to be equal. What about 1 and 2, right? 1 divides 2. Well, that's true because 2 can be written as 1 times n, where n here has to equal to 2, and that's in fact an integer, so that's true. What if we flip this around? 2 divides 1. Well, that means 1 can be written as 2 times m, where m has to be an integer. Well, that's not true because m here would have to be 1/2, and 1/2 is not an integer. So we can't look at cases like this because then this is not true. Okay, interesting. So far the only ones you could think of where this is going to be true is that when they're equal. What if, and we've tried 0, we've tried positive numbers, let's now try negative numbers. People do oftentimes forget about negative numbers, including myself. In fact, I didn't even know the solution to this until I looked at the solution and I was like, oh, right, negative numbers. So let's try -1 and negative 1. -1 and negative 1, this is in fact true, they do divide each other because -1 can be written as -1 times k. K here just has to be 1, right? Okay. What if we do a mix of positive and negative numbers? Well, okay then, if we do a mix of positive and negative numbers, we then ask ourselves, is this true? 1 divides -1, and -1 divides 1. Well, does this fit what we're trying to look at here? Well, let's see. -1 can be written as 1 times m, and in this case, m would be equal to -1, and that is in fact an integer, so this part is true. What about the other half, right? The other half, we're asking 1 can be written as -1 times, let's say, n. N here has to equal to, well, -1, which is in fact an integer. Okay, so it's looking like we have this part down. Well, then is it true that the two numbers are equal to each other? Well, no. It is not true that 1 is equal to -1. So clearly this statement is not true for all pairs of A and B. So that means that we need to write out the negation and prove that the negation is going to be true. So what is the negation of a for all statement? Well, if I tell you all cars are blue, all you have to say is, well, there exists a car that's not blue, so your statement is false. Same thing here, we say there exist integers A and B where A divides B and B divides A, but A is not equal to B. Now, how do we prove there exists? You just give an example. It doesn't matter. If you want to prove to me aliens are real, you just have to show me one alien. That's how this kind of reasoning works. So we start this proof by saying, let A equal to 1 and B equal to -1. Then 1 divides -1 and -1 divides 1. You can maybe prove that 1 divides -1 and -1 divides 1, but I'm going to say you don't have to because that is what we're supposing, right? And then we can say, but -1 does not equal 1. There we go. The proof is super duper short, but the reasoning is a little tricky because you have to, it's really easy to fall into the trap of, oh, of course they have to be simple, but you have to really try everything. You have to try your zeros, you have to try your negatives and your positives together, not just negatives with negatives and positives with positives. So there we go. We have proven that this statement is in fact false because the negation of the statement is true. So we can say, in conclusion, because the negation is true, the original statement is false. Fantastic.